what, shouldn't those resistors be 2 6s?
No, because there's no voltage drop.
No, like, so it could even equal out 0.01.
No, because it's an open.
Even if it's open.
Even if it's open, because this is all potential, and that's why I thought it was 0, but it's 12, and that's why I was asking
But that's just potential voltage.
Yeah, as long as that switch is open, it's just potential. It's not used up across the resistors.
Yes.
There's no current flowing. As soon as current is flowing, as soon as current starts to flow, I'm not gonna have 12 volts at the end.
Okay, so.
For example, make that 4 and 2.
4 and 2.
Yeah, so I can show you on the resistors.
So the resistor.
Yeah, 4 ohms and 2 ohms.
Yeah. 4, 2.
Now close the switch.
Yeah, that's
There you go.
Okay, now we have current flowing,
Yeah.
right? But now how much current we have flowing? What's the current in that circuit?
And plus this is 6 divided by that equals 2 amperage.
2 amps, right? I see that? That's 2 amps, right?
Yeah.
Now, I want to see here, each load is going to drop voltage. How much it's going to drop depends on the resistor. The first one is 4, the other one is 2. So now you're going to measure the voltage drop. Now do the voltage drop now on each one. Make a voltmeter on top of each one.
Okay.
Put a voltmeter on top of it, like I do.
Like this.
Yeah, no, like a, come on man, you got to be teacher, right? Come on, man. Voltmeter.
Yeah.
Try and draw the left hand on both of them.
Okay.
The side,
Get your teaching skills on.
the side of each resistor.
Okay.
All right, now you see what he did, right? So each load is going to use up voltage, okay?
Yes.
Now because current's going to be flowing. So you're going to use Ohm's Law to figure out how much voltage is going to be dropped, keyword drop, aka used up across the load. Okay, so now do the voltage drop across each one.
So this is 8.
Right, that's going to drop in the old one. It's 2 amps in the circuit, right? Y'all understand that? It's 2 amps, 4 ohms. Now we can tell how much voltage is going to be dropped on that light.
8.
8, exactly.
8, but then you gotta subtract it by 12.
Oh, hold on, let's put 8 up there. Put the 8 up there.
Yeah, my bad.
How about the other one?
4.
It's 4, right?
Yeah.
The voltage drop should always equal source. 8 and 4 is 12. 12 volts, right? So that's right.
Exactly.
Okay, so now, erase this for a second. Erase this right here. All of it. Put a voltmeter here, here, and here.
That's the other one.
Make it touch this, and this. No. Available voltage.
Available voltage.
Take this one. Take one line off.
Okay.
Like that. And put a voltmeter, a line right here. For ground. Okay. Same thing here.
Okay.
Ground. Make it touch this side right there so I won't get confused.
Okay.
And ground right there. Now, going back to the other question you just asked. Now we're going to do available voltage at each point. This line right here at A, how much should it be?
12.
12, right? Go ahead. It's 12. Now, that used up, that's 12 volts going to it from the battery source, right? Because there was no load. So that should be 12 volts. Now, David,
Yes.
on B, what's that?
B, 8. It should be 4.
Yeah, it should be 4. Now, why is it 4? You do
'Cause
the
it's-
math for you. Understand why it's 4?
Yes.
You understand it?
What do you do there?
Do you understand why it's 4?
No.
Explain to him why it's 4.
It's 4 because you take the source voltage and you subtract it by the potential with the drop.
No, the drop, exactly. Not potential, the drop. Now it's a drop.
Now it's a drop. We're dropping it right now.
4 on the bottom again?
4 is right here because that's the ohms.
That's the ohms. Put the omega sign, they won't confuse. Put the omega sign next to it. And next to the 2. All right. So do the math over here. Put 12, David. Put 12 right there. That's 12 volts to the V. So I get 12. 12 volts. Manage an 8-volt drop. It's 4 volts left over. Right. It's 4 volts. So So I had to push. It took 8 volts to push the current through this resistor. Okay.
Yeah.
What's left over is 4. It's right here. Because it used up 8 here to push the current through the resistor here. So what's left over is 4. Now, the next load is going to use up 4 also. Okay? So on the other side of it, yeah, okay, that's good. It's 0 left. So I should be near 0 on the opposite end, on the ground side. That's a complete circuit, because now all the voltage was used up. Okay? Now, if you open that switch up, they all go back to 12.
Yeah, like you said, yeah.
Open the switch. Open the switch.
Now we got it.
So, now, as soon as you open that switch up, as soon as this switch is open, there's no current flow. So everything you did doesn't count,
Erase everything.
right? Now we're gonna have, we said earlier, 12. Erase that
What's the
0,
first one say?
0,
Or there's no other box on the
0. Now it's gonna be 12, 12, and 12.
Yeah, it goes back. 12, 12, 12. It's open. There's nothing there.
And at the end, also 12.
This one's in 12 as well.
Yeah, because it's touching here,
yeah.
not here.
Yeah, that's true.
So you get that? So as long as the switch is open, remember this. Anytime the switch is open, I'm gonna have, I'm sorry, I said that wrong. What I wanted to say. Anytime I had 12 volts, I'll source voltage through the whole circuit like this. That means you have no ground, because it's not dropping.
Okay.
You get it? Raul, you get that?
Yep.
You get that? Everybody get it?
It only travels.
Does that answer your question?
Yeah, it does. Because that was because I've been thinking about the first test and I know I didn't get this one right, but I saw the notes, I see it now,
Yeah.
but like I just wanted to double check, I know. But I got the concept now because of the open switch, that's all.
Yeah.
Can we do